And now it's my pleasure to introduce today's presenter, Rachel Lambert. Rachel is an associate professor in special education and mathematics education at University of California, Santa Barbara. Before becoming a professor, she worked for over 10 years as both a special education and general education inclusion teacher in New York City and Los Angeles. Dr. Lambert researches UDL in the area of mathematics, as well as neurodiversity in mathematics. Her goal is to increase access to meaningful mathematics for students with disabilities. Her best-selling Corwin book, Rethinking Disability and Mathematics, a UDL math classroom guide for grades K to 8, is the focus of today's webinar. And now I will turn it over to Rachel.
All right, thank you. I hope everyone can hear me. I hope everything is all set. Coming to you from Los Angeles, California this morning. And I'm really excited for everyone to be here. Please use the chat. I have it open and wide so I can check it out as I'm presenting because I can't see anybody. So I like to hear from people. And I'm trying hard not to respond to all the places you're from. Because, for example, somebody just wrote Rhode Island, and that's where I grew up. So I'm very excited about that. But I'll be calm. All right. So my name is Rachel Lambert, and again, I was a teacher. I was a classroom teacher for 10 and a half years before I left the classroom to get my PhD. And the reason that I left was because I had no intention when I first became a teacher of becoming a math teacher. I was really interested in disability because I had grown up in a neurodiverse community and a neurodiverse family, and I knew that people that I loved hadn't been treated well by the schools. And so I was really passionate about that, but I thought I was going to teach English. And I then ended up moving to a school where I was going to be a fifth grade teacher, and suddenly I needed to teach math. And I wasn't particularly excited about it because I didn't think math was that interesting. I just thought it was a lot of memorization because of the way I had been taught. But once I started teaching it, I loved teaching math more than I loved teaching reading, which was terrible. It was upsetting, but I began to be really fascinated by teaching math. Fifth and sixth grade math is absolutely the best. And engaging kids, especially ones who walked in thinking I'm not good at math, which a lot of kids did. And what I noticed was the more engaging I made math, the more connected to kids' lives, the more we really dug deep into fascinating problems and cool strategies, the more my students liked it, including my neurodiverse and disabled kids. And then when I looked into the research on this issue of special education and mathematics, I was pretty shocked by what I found, which felt like a lot of deficit thinking about kids. I found research articles that said, kids with learning disabilities shouldn't be exposed to problem solving because they can't do it. And I was like, I know that's not right. And it wasn't right deep down for me. So I ended up going back to get my doctorate to become a researcher in mathematics and disability. And so I've been doing since then, I don't know how many years it's been. It's been about 15, 16 years, and I've been doing a lot of research. I do research on research. I look at the difference between special ed math and math education research. I've been doing a lot of intervention research. I visit a ton of schools. I'm always looking for amazing examples of teachers doing amazing work with kids with disabilities, which exist, but we don't really hear their narratives. And that's what this book is about to me. It's about shifting deficit thinking. It's about reframing disability in mathematics, and I'm super excited about sharing it with you today because this book took me a long time to write, and I'm super glad I published it with Corwin and that people are reading it. So thank you. All right, so today we're going to start by rethinking disability. You see, I'm just using the cover. I like the cover a lot, so I just use it. We're going to start with rethinking disability. Then we're going to think about rethinking disability and mathematics together. And then we're going to start thinking about where does UDL math come from? Think about universal design for learning, and then go into UDL math. And we're going to end our session today by looking at narratives of kids learning mathematics and think about how we can design around kids' experiences and the way kids feel about different kinds of math learning. So that's what we're going to do today. I'm very excited. Oh, someone just asked how we define disabilities. We're going to go into that. I love that question. All right, so first, when I'm talking about universal design for learning, universal design for learning is for everybody, for every kid in every classroom. I think done well, it really makes it accessible for a wide range of kids. At the same time, in my particular work, because of my interests, because of my experience, and because of what I think really needs to be done, I center disability when I talk about universal design for learning. I center kids who are at the margins for various reasons, like in the schools that I work with in California, we have a lot of students who are English language learners, and a lot of those students also have disabilities. And I'm trying to think all the time about how to serve those kids. So the kids who are not getting served right now. And so disability really is central to the way I think about UDL. Disability was my first question. I came to UDL because of my desire to figure out how to serve kids better with disabilities. So when I'm thinking about disability, I'm thinking broadly about it. So let's dive into that. So when we think about disability, does anybody in the chat know what this image is of? Yes, the fight for ADA. So this is the Capitol steps in Washington. It's the yes. It's this was a protest that happened in 1990 that called the Capitol Crawl, when the government was said it was going to pass the ADA, the Americans with Disabilities Act, but it did not. It kept stalling on doing it, which was going to make all kinds of aspects of American life more accessible for people with disabilities. And when they stalled, a bunch of activists with disabilities, and this woman you can see here, she's wearing an ADAPT t-shirt, which was a group out of Berkeley that was did a lot of sit-ins and like bus walkouts to try to fight for the rights of people with disabilities. So the reason that I'm so interested in disability, right, is because I believe in a real true kind of inclusion. So when I think about inclusion, that's just not like kids who have IEPs or have disabilities like being included with all the other kids. Inclusion is kind of for all of us, and it's about figuring out how people are excluded, barriers that exist, and fighting against them. So it's not like a thing that's one and done. Like, as we all know, and teachers really know, it's not about including a kid in a classroom, because what's that kid's experience? What's everybody's experience? What's a teacher's experience? Inclusion means we're going to work together and we're going to make it better, and it's not going to be perfect from the beginning. So inclusion needs resources, teachers need time, and for me, it's a moral imperative that we work towards, and it's hard work. It's not perfect. That definition comes from Slee and Allen, who are disability studies scholars. And so one thing that I also want to make sort of be like very transparent about at the beginning is the way I talk about disability. So here's the statement that I really believe in. Inclusion of people with disabilities in society has only come through continued struggle, led by intersectional activisms by disabled people. This is why I'm showing this slide. It's like a lot of people don't know about all of the work that disabled people did to actually like pass these laws. We just learn about the laws. As teachers, we learn about IDEA, and we don't learn about how people fought to get that passed. And so when I'm talking about this, I'm going to like try to center the experiences and the fight and the perspectives of the people who I think know best and are the experts, which means people with disabilities and neurodiversities, as we'll talk about a lot today. So I'm going to use person first language, which means people with disabilities, but I'm also going to use identity first language, which there are a lot of adults with disabilities who prefer identity first language. So disabled people, and that came from the autistic community. So a lot of people with autism prefer to be called an autistic person because they think of autism as central to who they are and not secondary. So I use both as I talk to respect different people's points of view. When we're talking about disability, I made this graphic, which is in the book, just to remind us that it's really complicated. Sometimes disability or special education gets oversimplified in schools. Like certain of these are the categories in IDEA where kids get services. But it's usually way more complicated than that. Like if we think about autism and ADHD, for example, a lot of people feel that they have both more and more. More people are reporting both ADHD and autism, right? And everybody who has a disability is also like a human being and has had a certain set of experiences. So what I want to remember is that when we're thinking about disability, I'm not going to talk about the federal definition of disability, which is for adults. It's something that impacts your your ability to live everyday life, which means lots of things. It means anxiety and depression. For kids, it means behavior disabilities, emotional disabilities, and for adults, it means all different kinds of emotional differences. But disability is also an identity, a community, and a social justice movement. It's all of those things, and it has been. It's just educators and the general public don't really think about it that way. But that's how a lot of people in the community think of it. And just so, think about how complicated it is for a second, let's think, wait, if somebody told you that all people in all of these categories need the exact same kind of math teaching or the exact same kind of anything, should you believe them? I think you should question that. Disability is pretty complicated. It changes all the time. Categories change, and people need different things. And anybody, even in any one of these categories, is complex, and not everybody needs everything. We're going to talk today in depth about dyslexia and mathematics, actually. So it's going to be fun. But not everybody with dyslexia needs the same things in mathematics, and that's been well established by research. So it's complicated. That's the summary. All right, so we're going to think a little bit about the way our society thinks about these. So we're going to think about dyslexia today. So we'll start with learning disabilities, which is like the large umbrella category that dyslexia is generally underneath. I'm so excited to talk about dyslexia. I grew up in a family of people with dyslexia, and it gets me very excited to think about it from a non-deficit point of view. Okay, but let's look at this. Looking at this image, this is me just Googling, actually like less than a month ago, learning disabilities. And here's the images that show up. What do you notice and what do you wonder about these images? Oh, wow. You guys are giving me such good answers. There's so many of them. All right. So the next, I'm hearing a lot of frustration, kids. So we're going to look at a certain subset of these first. So here, this looks very similar. I did this like maybe 5 years ago, and I saw images just like this. So primarily then, or almost completely, the images did have to do with the brain, but if we looked at the images that actually had a child, it's like children mostly by themselves and boys, and mostly white boys or completely white boys. It was hard to tell, but they generally look like they're white. And do you see, like, there's so much confusion and frustration. There's this kind of way of doing this artwork that make the kids look really unhappy and really, really frustrated. If you look at that, this was a newer one, but the one in the upper left-hand corner, the kid with you see him learning disabilities, and there's a chalkboard. Do you notice what the math is like on that chalkboard? The kid's like, what is he, like 6 or 7? And look at the math they put up there on that. I'm like, no wonder that kid is upset. Like, he's doing algebra on a chalkboard. They shouldn't do that to children. But if you look at all of these images, what are we thinking about here? We're thinking about learning disabilities in general, which includes dyslexia, but it's not just dyslexia, as this individual sort of alone kind of time. Now, here's some images that when I did this 5 years ago, didn't exist in this search. What do you notice about this subset of those first images? Yeah, finally some girls. There were no girls when I looked up learning disabilities. In that first group of maybe 35 images, there weren't any girls. Now we see girls, slightly more inclusive. And look, there's 2 girls together, like learning maybe math together. I don't know. I'm so happy that they have a friend that they're together with. Also, we have an adult who doesn't look sad who's teaching a kid, which is very, very nice. The girls, if you notice, is definitely more likely to be mathematics. So the girls are sort of conceptualized as having dyscalculia, where the boys are conceptualized as having dyslexia, which is not great because we know both boys and girls have both differences. And so it's not particularly wonderful that we have that consistency in the way we understand it, but they're not quite as stressed. Even this girl who has she's looking scared. And once again, actually, I just noticed this in the top right-hand corner, we have a very young child looking very confused about mathematics that she should not be learning for like 10 years. Like, yeah, you don't need to learn that, girl. All right, so things have gotten a little bit better. And as last time I showed these, somebody noticed that one of this is about adults, which is wonderful because there's a growing understanding that adults can continue to have difficulties with what they had difficulties with in the past. And here's two things that I just wanted to pull out, which is that neurodiversity becomes something that is talked about in this Google Images. So there's sort of, yeah, it is so weird, the math. I got to analyze the math in these images, like how they decide what it is. So here we have three models of disability. The first one is the medical model of disability. This is really useful when you have a medical problem and sometimes can be exactly the right thing to that people with disabilities want, which is, I have a problem, I want it fixed. I want to go to the doctor, I want a remedy, and I want to be fixed. But when we think about that, using that all the time in education, it doesn't work because the kid's just by himself. We think the problem is within this poor little child, not the fact that these books are really too big, right? It's the second way to think about it, which was created by disabled activists, is the social model. And that doesn't mean that disability doesn't exist and is real, not at all. That's not what they were saying at all. What they're saying is it's also produced contextually. So it depends on what the classroom is like. It depends on how the child is taught. It depends on their emotional state, how they interact, how they learn. It's contextual, which is something we also understand from like developmental science, that learning is contextual and it depends on what we present to kids. It's not all, the same kid is not going to have the same learning experience in different classrooms that use really different ways of teaching. And then the last way is neurodiversity. This image is from a colleague of mine who has two neurodiverse kids, and she made them a cake to celebrate their neurodiversity anniversary. And do you see the brain she made with frosting? Isn't it awesome? So neurodiversity is an idea that was created by neurodiverse people. And basically it's like, listen, humans are diverse. We're diverse in our attention. We're diverse in how we engage. We're diverse how we process sensory information. There's a lot of ways that we are diverse and variable. And it's not bad. Like, it's not necessarily bad. Don't shame people for being different in the way they take in information. Instead, think of it as a set of challenges and a set of strengths. And that's makes so much sense to me. I think that's the way I was actually raised. And so I really connect with that. It seems like it makes a lot of sense. And it's a really practical way to think about it as a teacher. Yeah, some things are going to be hard if you have autism, but also you have strengths. And those strengths can be exactly the way that I teach you and reach you and help you grow. So I said we dive into dyslexia a little bit. Just to give some context, learning disabilities, like I said, is this category. And there's different ways to parse the inside of that category. Like there's auditory processing, which I don't have in here, which is used in some places and not in others. But when I started becoming a special ed teacher, that was definitely a really prominent subcategory. But here we're just sort of talking about three major areas, which is that a real difference in the way you learn to read, the way you learn math, the way that you can engage in writing. And people can have both things, right? They can have all three things. So dyslexia is the most common of these differences, and people estimate it's 5 to 10% of the population. And a new study, this is an amazing study if you're into dyslexia and math, you should totally read it, it's so cool. But it's about the variability across dyslexia in mathematics. And the differences that people have in math with dyslexia are really different. Some people have trouble with procedures, some people have trouble with memorization, some people have strengths in geometry, and we'll talk about that in a second. All right. So a lot of times when we talk about dyslexia or any learning disability, we use the medical model. So we talk about challenges. So these are challenges across a lot of research. There's citations in my book for this. I should have put them on the slide. I'm sorry, but I forgot. But these are basically, not every person with dyslexia has these differences, but it often occurs with people who end up with a diagnosis of dyslexia. Difficulties in phonological processing or hearing and parsing sound, language, memory for facts and procedures is often particularly a difficulty. The memory for facts and procedures, like in mathematics, is processed in the verbal centers of your brain. So for people with dyslexia, that part of math, that memorization, is in the verbal part of your brain, which might not be the part of your brain that's the strongest. Working memory and executive functioning can also be challenges. But what about strengths? So strengths, and here's a book that I cite in my book, and I love, called The Dyslexic Advantage, that goes through a ton of the research that exists on the strengths of people with dyslexia. There should be much more research in this area. We know a lot more about what's hard for people with dyslexia than the strengths, and I wish research would change and catch up. But this gives you a great idea. So one area of strength can be visual spatial processing. It can be creativity, pattern finding and seeing connections, seeing the big picture, and narrative thinking. So for example, there's like two kinds of memory that people talk about. That one is declarative memory. That's the memory for like facts and like remembering phone numbers. And then there's episodic memory, and that's narrative memory. It's like remembering how it felt to be in a particular space, how a story of what happened, like memories of like your existence as a human being or stories that happened. That's episodic memory. And often people with dyslexia are stronger episodic rememberers than declarative rememberers. Rememberers is not a word, but I just made it up. So you see, I'm a professor. I'm going to make up a lot of words. So now here's the question. Just think about this set of challenges and strengths, remembering that it's not the same for everybody, right? But if they are broadly true across the category, how would that matter in math class? Oh, they're so exciting. Your responses are really exciting. I hope you're getting a chance to read them. But I'm seeing a pattern of understanding that memorization of facts might be difficult, that connecting to concepts, connecting to narratives, connecting to like seeing patterns in mathematics might be a strength, a way to leverage strengths for people with this learning profile. That word problems could be difficult, but is important because word problems have a story. So I don't know, looking at this set of strengths and challenges, sometimes I hear, oh, we shouldn't give those kids word problems. Well, we shouldn't hand them a word problem that they can't read and expect them to figure it out. But that doesn't mean we shouldn't use context and situations, because that's narrative, right? That's finding patterns. All right, so this is a colleague of mine, Edmund Harris. He's in the book in chapter 3, and he has a webpage that I linked to on my blog. And he is a dyslexic mathematician, and him and I teamed up to do a research project on dyslexic mathematicians. And you can see that article here. Oh, sorry. It's called Insider Accounts of Dyslexia for Research Mathematicians. And if you go to my website, mathematizingforall.com, if you go to my research, every research I've ever written, I have posted there at full text access for you, so that teachers can always get my research. All right, so when we did this project, what we looked at was we interviewed only 5 dyslexic mathematicians, and we asked them a lot of questions. We looked about their life histories. How did they become mathematicians? Like what were barriers for them? And we found that barriers were basically very procedural mathematics were barriers for them. And things became different once they engaged in more conceptual mathematics. So let me show you. Oh, Edmund also did a coloring book, a mathematical coloring book. He's done multiple ones. That's one there, Patterns in the Universe. So this is not from one of the research participants, but it's a blog post that I found that Edmund and I sort of started to work from. This is a dyslexic research mathematician writing about dyslexia and math. As a dyslexic, I've never been good at calculations or recalling rote facts like times tables. Here's the thing, beyond a certain point in mathematics, it's not really about calculations. Geometry class was when math became interesting and easier for me. Suddenly I was in a world not of strands of symbols to be processed, but of shape, space, lines, angles, concepts, and narrative-like proofs. Suddenly everything made sense. So when you think about that quote and then go back to those strengths and challenges, it was not true for everybody, but we definitely heard from people who loved and excelled in mathematics and had dyslexia that certain aspects of math were particularly hard for them. Rote memorization, and what was easier for them was things like geometry. Somebody predicted this in the, I don't know who it was, but they said that it would be easier. Maybe geometry would be easier. Well, geometry gives us multiple modalities to work with, right? So that makes a lot of sense. All right, so we were just talking about rethinking disability, but now we're thinking about rethinking math and disability together. So a lot of times people think of math as like a ladder, right? And when math is a ladder, you got to master this, you got to master this, you got to master that, and you got to master the steps at the bottom before you go on. But in our study, for example, we found that of the 5 research mathematicians with dyslexia, 4 said they didn't know their times tables. And they said that they derived it. They would basically figure out from other facts. Edmund, you always use square numbers to figure out it because he loves square numbers. So, but the memorization of the like a 6 times 7, they had to redo it because it was very, very hard for them to memorize that combination, right? And we talked about why that might be true because it's actually stored in that verbal part of the brain. So this set, what if we had decided that those kids couldn't move on until they had memorized their tables? What if we kept them here and didn't let them move on? This is a particularly dangerous assumption for neurodiverse kids, for dyslexia, for ADHD, and for autism, because in my experience, the kids who are neurodiverse often have unusual ways through the mathematical landscape. So we could think of it as a web, for example, or as a landscape. But here I have a beautiful spider web where not everything depends on everything else, right? Well, this is true certainly for dyslexic mathematicians who haven't memorized their multiplication tables, but clearly are like topologists, they're doing research in mathematics at a university level, right? So they can do mathematics. They maybe skipped some layers on that ladder, but it didn't necessarily affect them unless they weren't allowed to move on. Often I see IEP goals that are down at the lower ends of these ladders, and kids may get them year after year and not make progress. And that really, really upsets me because there are some kids who are just not going to memorize certain things, but yet they could do much more advanced mathematics, much more complicated mathematics. And I see that a lot. That's something always to remember when you're working with neurodiverse kids. Another metaphor that I talk about in the book is the idea of like building a house. So recently I wanted to do something to my house and I hired someone to come and look at it. And I said I wanted to knock a wall down, and they said that I couldn't because it was load bearing. It was very upsetting because I wanted to knock this wall down. It's the first time I ever wanted to do work in a house in my whole life, and I had to be told no. Apparently I could do it if we like put in a support bar, but let's think about that. Let's think about mathematical learning perhaps as a building. It's growing up, right? There are things that really matter. Like I would argue to the end of time that understanding concepts of a fraction and becoming fluid with fractions is really important. I'm not saying it's a ladder because all this stuff is not linear, but even if it's complicated, that's a really crucial node for kids to move on to higher math. So I would say fractional understanding is a load-bearing wall. It's worth extra time, it's worth extra investment, but not everything is. Understanding what subtraction is a load-bearing wall. The subtraction algorithm to me is not a load-bearing wall. For some kids, it comes really easily and it's wonderful. For other kids, adding on to subtract is a much better strategy. And research shows that strategy is more successful for students with disabilities. So why would we care if they can do it one particular way? That's not a load-bearing wall. So the idea is that we try to build up. So what's really important is for us as teachers to know what really matters and what we can sort of work around, right? Oh, you guys have such good ideas. Oh gosh. These are really important ideas. I love them. All right, so continuing this idea of like rethinking mathematics, something that I think we've gotten sort of convinced of that I really want us to question, and I bet you lots of people on this call are going to question too, is this false deficit binary. Like we are sort of trained to think that there are I'll do it here. Here we go. Low kids, IEP kids, strugglers, these terms that I hear all the time. And then there's my high kids. And we are sort of trained to think they need different mathematics, that these kids need to be told how to think. They need explicit instruction. They need procedures. And that somehow the high kids are the ones who can handle inquiry, instruction, and concepts. I do not believe that this is true. It comes from research, but it comes from sort of a misunderstanding of the research. And this is something I've studied in depth. So, for example, the research that's done in special education mathematics is almost all about explicit instruction. And so almost all the instruction that includes kids with disabilities is about explicit instruction. And so it's no surprise that what they're finding is explicit instruction is effective. But it's mostly about being effective for procedures and facts and memorization, because it's that group of research doesn't study conceptual understanding in depth. This is the group that calls itself the science of math, and I've done some work around sort of unpacking that group if you're interested. Then we have like inquiry-based mathematics, which is something I believe is really important. I actually believe both things are important at different times, but inquiry-based math is what kids with disabilities need a lot more access to. They don't get enough access to it. And math ed education has actually just not really included kids with disabilities in publications, or when they talk about it, or when they talk about equity, it doesn't always include disability. And that really bothers me. But this is not a teacher problem. This is a research problem. This problem is created by the researchers having their own sort of set of assumptions about who benefits. But then they sort of give it to everybody else, right? I don't like it. We don't like it. I'm not into it. This is a webinar that I did for NCTM, which if you're into this slide and you're like, I would like to know a lot more about this, and you're really nerdy, feeling really nerdy right now, just search NCTM Rachel Lambert webinar, and you can hear me talk about unpacking the real differences between these research traditions, and you can go much deeper into this question. It's complex. So we need to move away from deficit thinking and deficit pedagogies. All kids should have not inquiry, but guided inquiry. So in the research around inquiry, it's unassisted, like discovery learning. We don't do that, and that's not effective. What's effective is inquiry that includes guidance, like scaffolding, like questioning, like all the kinds of beautiful things teachers are doing all the time to engage kids, make sure they understand, asking questions, having them talk to each other, sequencing problems. All those things are guidance. And we want to make sure that all kids have access to grade level instruction. All right. So now let's think about how to get that done. So I'm talking here about UDL math, but it comes from a tradition of universal design and universal design for learning. And we're going to look at all of those. So let's start with universal design. This was the oldest of these traditions, and it was created by this gentleman, Ronald Mace, who was a wheelchair user and an architect. And he developed this idea that design that's universal, it's not one size fits all. That's not what he meant. What he meant was, if you design a building so that only certain people can get in, this is like a waste of time, energy, and it's not inclusive. If you design buildings so that more people can get in, more people can use them, this saves you time, energy, and it's more inclusive. So it's sort of about simplifying the process by thinking about the diversity and disability and access needs from the beginning. It's not about a way to make everything more complicated. It's a way to make things simpler and better designed. So one of the things is that because it's a design point of view, the empathy becomes really important. Like you want to begin with empathy. So one example of this is this kind of, does anyone have this kind of potato peeler still? All right. So like a famous example of universal design was this one. It's called the OXO potato peeler. And if you can see it, it's got this oval holding, right? And it has ridges. So this was designed, a product designer who specializes in household items. His wife had arthritis and they were on vacation together. And she got really mad at him because she was like, you're supposed to be an expert in design and I can't even use this other potato peeler because it hurts my hand. I can't do it. Why can't you design a potato peeler that I can use? So they worked together to design this over years and actually transformed the kitchen utensil industry, which hadn't really been transformed before that. So they made it so that it's better for her. She has arthritis, but it's also better for my kids if I want them to like peel a bunch of potatoes for like Thanksgiving dinner, right? So it broadens the reach. So let's look at one more example of this. Here's a Rubik's Cube. Who is this not accessible for? Yep. People who are colorblind, people who are blind, some people, certain motor skills issues, right? All right. Now you could think about what would make it more accessible. Let's look at two examples. So if I give you A and B, these are two different redesigns of this tool. Which is more universally designed? We're getting a lot of consensus on B. All right, why is it more universally designed? Shapes, not Braille. Everyone knows the signs. Yeah. So the A1, it won an award, according to Meyer et al., which is a book about universal design for learning, where I got this example. This one, A1 won an award for like redesign of the Rubik's Cube. But if you look at it, you start having some questions like, I don't think that I could use it because I'm not familiar enough with the Braille symbols to be able to differentiate that, right, if I'm really working on it. Also, most people who are blind actually don't read Braille, like worldwide. So it's not even necessarily well designed for that broad group of people. It's designed for a subset of people who are blind who also read Braille. And other people can't use it. So because it doesn't have colors or indications, it's like for a narrow group. And sometimes we want to design something for a narrow group of people, right? Like a really specific need. There's something wrong with that. But that's not universal design. Universal design is B, because B, it has different colors and it has raised shapes. So you can use both things to help you like enact it so that it's just more universal. So the people who could use Rubik's Cube was this much. Now it's this much. Every time we're making our classrooms more accessible through multimodality, through different ways to engage, we're just opening up the range of kids that can engage. I don't know if they actually constructed B. Somebody just asked the question. A may have won awards, but B probably sold more. B might have been a prototype that never got made. Sad. We should definitely make it. I love it. So universal design for learning is often presented as a checklist. I got this from my home state. I just randomly grabbed it. Rhode Island Modified UDL Checklist. So I don't know what this is supposed to be for, whether you give it to a teacher assesses themselves on the UDL guidelines. I don't like this. This is not, to me, what UDL is. Also, like, what if someone comes in and like tries to see if your classroom is UDL or not? I don't think you see it. Some of the research they do on UDL is on like lesson plans of pre-service teachers. Do you really think we can see that what UDL is there? UDL is a verb. It's a process. It's a way of being. It's not a thing. So myself and a lot of other people thinking about UDL right now are instead we think of it as a process, as a mindset. And this like woman here is my teacher icon that I got from Canva, which she's just like, she's thinking, she's always thinking. And that's what a UDL teacher is to me. Somebody who's always thinking, teacher as a designer. So that's the way that I like to think about UDL. It's about teachers are natural designers. Well, I mean, I was a teacher for 10 years. I know we have to solve problems constantly. And some researchers of inclusive classrooms find that creative problem solving. So when you don't see the kid as the problem, but you say, oh, wait, I could fix this problem. Let me redesign this thing, right? That natural inclination of teachers, I think, is what I want to build on to make classrooms more inclusive. It's not about checklists. No. So universal design for learning has a couple basic tenets. The problem is not the kids. The problem is a one-size-fits-all curriculum. Classrooms will be better if they include all students. The more we can open up, we're opening it up not just for those kids, we're opening for everybody, right? We're designing from the margin. So if we want to open something up more, we need to figure out what's not working for the people out here, right? That's how we open it up. The goal is not like just memorization. It's not just increased test scores. The goal of UDL is clearly expert learners, purposeful, resourceful, strategic learners. And a core way that UDL helps us understand students is by focusing on that variability that I've been talking about a lot. I don't want anybody to see dyslexia as one thing or another. I want us to think about variability, right? So we all vary in different ways. So thinking about a college lecture, so I use this with my undergraduates, and I didn't know if you guys would like it, but we think about this teacher is about to give a lecture to these students in a college classroom. The goal, what might be the goal of that? So first, if we're thinking about UDL, we want to know the goal of the teacher, their objective. We want to know what barriers there are to accomplish that goal. So what are the barriers? Just looking at this picture, perhaps having a similar experience yourself. What are barriers? If we think about learner variability as this very flexible way of thinking about our differences, right? And how might learners vary in this situation? So those are the three questions. We still have this image here. What are the barriers here for the learners, and how might learners vary? So far, I'm seeing the stairs, attention span, motivation, vision. So I'm assuming the stairs are a barrier. Different people might vary in their vision, how well they can see. I like just boring. It might be boring. We're all assuming it's going to be boring. Maybe it's really fun. I don't know. Taking notes. So I'm seeing a lot of notebooks. There's definitely an expectation that they're going to take notes about what the professor is saying. Oh, childcare, yes. So if we assume that the professor, probably their goal is to help the students learn some set of information, right? They're going to learn content. That's probably the sort of goal. Yeah, it's hard to collaborate with this. You can interact with certain people, but it's certainly not designed. It's clearly not designed for groups. It's designed for lecture, right? All right. So let's think about our Rubik's Cubes for a second. We could think about any one of these issues, but let's think about note-taking for a second. We could design something specifically for the people who have difficulty taking notes here, or we could try to make it more universally designed, right? So if we just went with what we're calling this A Rubik's Cube, we would have individual differentiation. So we would probably, as a university professor now, I have individual students with accommodations. So they'll have a note taker come that gets hired who's a student, or it can be a student in the class, and those notes go just to that student. They maybe have a scribing pen, maybe they get audio recordings, but they're just for certain students. So this is like this first Rubik's Cube. It's designed specifically for certain students. That's not bad, but that's not universal design. Because if we have to do that for all these different students, that's a lot of work and it's a lot of effort. But we could think about it like the second Rubik's Cube. So one of the studies they did in Universal Design for Learning in a university course at Harvard is experimenting with note-taking. One of their studies, they had, every time there was a lecture, they had 3 different students take notes, different kinds of notes. So some students drew, some students wrote like summaries, some students really took detailed notes. I mean, people like to take different notes. They're variable, right? So every class, there would be 3 different kinds of notes. So you could look at the one or pictorial one, you could look at the other one, and those were accessible to everybody. I've done that in my classes, and one thing I love about that solution is it's actually simpler for me. It includes the learners in the situation. I explain to them why we're doing that, and we think about what kinds of notes help everybody, and together, what kinds of different notes might help everybody. So everybody's engaged, people are becoming more strategic about who they are, and it helps everybody, right? And if you're going to do an audio recording, make it available to everybody. This is how we open it up rather than close it or do individual differentiation. I hope that's useful. This is a new slide, so if you could give me feedback if you want. So when we're thinking about mathematics, what is our purpose? What's our goal as math teachers? So I made this slide to think about what is an expert learner in mathematics. So at the center, I have this idea. To me, strategic sense making is what I want. I want it for all my kids. I want them to be strategic about their learning. strategic about math problems, but strategic about their own learning. With over time, this is what I want, and I want them to make sense. My students, like, the most important thing to me with students, especially ones who had experienced a lot of like procedural mathematics, was teaching them how to like embrace making sense. And it took time sometimes, and sometimes it was very quick. All I needed was a couple of amazing like problems that they themselves were fascinated by for them to sort of do this. For some kids, they need to sit next to the right kid and get that support from a peer. And some kids need a lot of practice just not being told what to think and instead thinking for themselves and trusting that they can do it. So these are a lot of different ideas that I think we want like kids to learn. And to me, UDL math is about helping them become the more strategic math learner, to understand themselves as math learners, to be able to advocate for themselves in the long term. So UDL math to me has just three things. Remember, I said it wasn't a noun, it was a verb. It's a process. So number one, math class is too narrow. The second one, we got to open it up. And third, strategic supports. So just because we open up math class, that's not always enough. Sometimes we have to add in strategic support. So that note-taking system, that's not just opening it up, like you can take notes however you want. That's adding something into the class, but it's strategically supporting kids. So those three gestures are at the core of what I think UDL math is. So math class is too narrow. There's lots of ways a math class can be narrow. Often math class is designed for a certain set of kids who are fast, who know it already, who sit still, who are organized, all of these things, which not all of our kids are. Well, we have maybe a couple, right? But there are a lot of different things that kids bring to classrooms that make them feel like math class isn't for them. They don't see themselves in the curriculum. They don't have a relationship with the teacher. They need extra time. They're developing in two languages. They can't sit still. Math class is emotionally overwhelming. They're labeled slow or low kid and they know it. All these things make it feel like math class is not for you. So how do we fix this? Well, let's think about students at the margins. So we don't have, this is the end activity. We won't have tons of time to do it, but here it is. So see this book here, Dyslexia is My Superpower. This is a book written by Margaret Rook, and it brings the narratives of kids with dyslexia from, I believe, from England, or I don't know. They definitely use the word maths a lot, so we think they're from England. And it has narratives. And so I paid my child $20 to read the entire book and pull out every math narrative so that we could look at them, right? So here they are. Elliot, 17, says, other kids had known I was struggling in primary school. It was quite obvious when it came to doing maths. We would stand into a line with the teacher facing the front of the queue. The teacher would ask, what's 9 times 12? If you got it wrong, you would go to the back of the queue and I was always there. I still can't remember my times tables. I can't quite place the information. Charlie, 17, said, I was always labeled not good at maths when this shouldn't have been the case. Schools put you in boxes and leave you there. Freddie, 10, said, in maths, I didn't know my times tables. I couldn't take them in. I only know my 2s, 3s, and 10s. Fiona, 15, says, I actually like maths. I like getting through it slowly and problem solving. What I like is that there's more than one way to answer a question. If I can't do something, I can get there another way. Max, 17, says, I'm very good at 3D, the hands-on stuff, and I'm quite good at science and the geometry side of maths. Elijah, 12, says, in maths, they were really quick at sums that took me ages. Molly, 13, says, I solve math problems in a different way. I visualize them. So, looking at these narratives, these are pulled randomly from a book about kids with dyslexia talking about learning in schools. What do we see? We're trying to think here, what are the barriers and how can we open up math class? So what barriers exist for these kids and what supports learning? Looks like people are starting very much with the first question. So what barriers exist? A focus on speed. We see that in more than one narrative, that these kids are saying speed is a barrier for me. And then offering multiple ways to show understanding as a way to support. it's definitely a barrier when the teacher makes them pee in a queue and puts the kid in the back. That's just, we could really unpack that for a long time. What's the kid's emotional connection to mathematics there? So, but what supports it is really interesting to think about here. So I'm seeing what supports kids is like giving multiple ways to solve a problem. Like as Fiona says, she likes that there's more than one way to answer a question. If she can't do it one way, she can get there another way. We have kids thinking about visualization. Oh, you can't see it in this one. Oh, sorry. I left out Molly's. Oh, Lord. Molly's is important. Molly's thinking about visualization, right? The same thing as that connection to geometry. All right. So one of the last things we could think about is we were just focusing there on dyslexia. Now, we talked about the same, we added in the fact that, I mean, a lot of those students with dyslexia I work with also are multilingual. They speak 2 languages. Is there a way we can connect the needs of these 2 different groups on the margins? Is there something we can do that serves both of these groups of kids? Yeah, visual tools. One thing that's really important is the multiplicity here. I find it to be a massive problem when the solution to kids needing little extra help in math is to make them do it one particular way, or to make them memorize many different ways. What's really important is that we try to figure out what kids understand, help them really grasp onto strategies that make sense to them and that work for them, and help them advocate for themselves that they should do it ways that make sense to them. Not ways that make sense to the teacher, ways that make sense to them, all the way across their education. All right, so this is where we're thinking about empathy, knowing our students and the purpose. Here are some of the things that definitely came up in what you said. Expand opportunities for visual problem solving, and that would work across multiple groups of learners. All right, so we're not gonna do these. But I wanted to talk a little bit about where I go with the stuff in the book. So one of the themes of the book is trusting kids' thinking. And here's a quote from it. When we as teachers trust in the thinking of our students, especially our students with disabilities, we create the conditions our students need to trust themselves as mathematical thinkers. When we, their teachers, believe that our students can and will solve complex problems, they will be able to. This is a core belief that I have, that the teachers in the book have. The teachers in this book, I talk about a lot of different kinds of strategies. So there's a teacher that uses counting collections with a K1 special education class. There's a teacher using thinking classrooms in a 2nd grade class. There's a teacher who uses young mathematicians at work and context for learning in a 2nd grade inclusive class to teach them about the number line. There's a chapter where I'm doing tier 3 intervention and trying to understand how to teach a group of kids multiplication. And there's another chapter that's about a teacher who uses visual patterns and thinking classrooms to teach an inclusive 7th and 8th grade classroom. And what's true across all these teachers is that none of these ways of teaching or these books, including mine, give teachers what they need to serve all kids who are complicated. The most important thing is that UDL means that you say, I am a creative person. I believe in this kid. We can figure this out. And I'm going to try to do it in such a way that I'm not doing a bunch of individual worksheets, but I'm trying to design for flexibility so that it works for these kids. That's kind of what I'm going for. And nothing's going to work for all kids. It's always going to be a process. It's always going to be like, you're going to have to adapt something, but that's how we think about it. We're always thinking about how do we open this up so it works with less effort from the teacher for a bigger range of kids. So that's it. By the way, today, before this, I made a Facebook group called UDL Math. I've never done that before, but I thought that a lot of people were going to come to the session, and I was like, well, if I'm going to do it, I might as well do it now. So hopefully people will have conversations and we can discuss things, and I'm certainly planning to like be on it and talk to people. So if you're interested in that, let me know. I'm on Blue Sky Social. You can also ask me questions there. And that's the picture of my webpage. I'm going to try to write more blog posts, especially with things that are coming up for teachers about doing this very hard work. And I'm really excited to engage with all of you. That's it. 9:26. I better stop.
Thank you, everyone, for joining us. And a big thank you to Rachel Lambert.